Number 10, we have values of g and g prime up here in the table. And we're told that g prime is continuous on the interval from 2 to 6, which allows us to work with this integral here. So we're looking for the integral from 2 to 5 of g prime of x dx. Alright, well, first thing we need to do is take the antiderivative of our integrand. The antiderivative of g prime is g. And that's going to be evaluated from 2 to 5. So we're going to plug in the 5 first and the 2 second. G of 5, here's g, here's 5. G of 5 is 15. G of 2, here's 2, here's g, is 10. So our answer is 5. With number 11, we have to solve for k. The process is still the same. Take the antiderivative. 3x squared becomes x cubed. 4x becomes 2x squared. K is a constant, so it antiderives to kx. This is being evaluated from 0 to 2, and we know that it will be equal to 20. It's not going to write it yet. We will in a moment. First we plug in 2. That gives us 2 cubed plus 2 times 2 squared plus 2k. X is 2. K stays there. 2k. That's fine. We're trying to figure out what k is. When we plug in 0, well, this is what's great about 0. 0 cubed, 0 squared, 0, it's all 0. Now that we've plugged in our values, I'm going to set it equal to 20. We have an equation. We can figure out what k is. 2 cubed is 8. 2 squared is 4. Doubled is 8. So 8 plus 8 plus 2k equals 20. 8 plus 8 is 16. So let's subtract 16 from both sides. 2k is 4, which means k is equal to 2. With number 12, same idea, touch more difficult. 2x minus 6 antiderives to x squared minus 6x. That's being evaluated from 0 to k, and it's going to be equal to negative 9. What happens when we plug in the k? We get k squared minus 6k. What happens when we plug in the 0? We get 0. So k squared minus 6k minus 0 will be equal to negative 9. We have a quadratic, which means you want the 0 on the far side. Let's add 9 to both sides. K squared minus 6k plus 9 equals 0. Now we can factor our quadratic. Two numbers which multiply to negative 6, which add to negative 6 and multiply to 9. Negative 3 and negative 3. So k must be 3. 13, we're told that f is equal to x cubed minus 3x squared plus 2x minus 1. G is the derivative of f. What's the integral from 1 to 2 of g of x dx? Well, since g is equal to f prime, let's rewrite this as the integral from 1 to 2 of f prime of x dx. Now, when we take our antiderivative, the antiderivative of the derivative of f is just f. And it's being evaluated from 2 to 1. So this is equal to f of 2 minus f of 1. When we plug 2 in up here, we have 2 cubed minus 3 times 2 squared. 2 squared is 4, tripled is 12, plus 2 times 2 minus 1. When we plug in 1, we're going to get 1 minus 3 plus 2 minus 1. 8 minus 12 is negative 4. Plus 4 is 0. Minus 1 is negative 1. 1 minus 3 is negative 2. Plus 2 is 0 minus 1. Negative 1 minus itself, this whole thing, is equal to 0.